Good evening. I am going to discuss JEE Advanced Paper 2 Math section held on 24th May 2015. Firstly, I would like to give a brief overview about the paper. The paper consists of 3 sections, a total of 20 questions. Section 1 comprised of 8 integer answer type questions, 4 for a correct answer and 0 for incorrect. Section 2 has 8 multiple correct answer type questions, plus 4 for a correct and minus 2 for a wrong answer. Section 3 consists of 2 paragraphs like comprehensions, each consisting of 2 questions. Again, the marking scheme there was 4 for a correct and minus 2 for an incorrect answer. We can clearly observe that this year's paper has a different kind of negative marking, that is 50% negative marking in some sections. Again, paper 2 was relatively more lengthier compared to paper 1, and overall we can say that the paper 2 of JEE Advanced Maths was a difficult paper. Okay, let's start discussion for the set 5 and question number 41. In this question, we are looking for the coefficient of x to the power of 9 in the expansion which is given here. Now, can I clearly say that since we are looking for the coefficient of x to the power of 9, that is going to be obtained by multiplying the first 9 brackets only. That is, can I say that if I will be multiplying the terms in the brackets beyond this, I will be getting 1 plus some other powers of x which are higher than 9. That is, they are not actually contributing anything to the coefficient of x to the power of 9. Since we also know that coefficient of x to the power 9 is basically the number of ways in which we can generate the term x to the power of 9. I am going to mention the all possible number of ways by which we can generate x to the power of 9 in this product. Now, one possibility is we are multiplying, let's say, 1 with x to the power of 9, which you can understand like I am taking 1 from 8 of these 9 brackets and x to the power of 9 from the one remaining bracket. The other possibility is, let's say, we are taking x and x to the power of 8. The third possibility is x square, x to the power of 7. Similarly, x cube, x to the power of 6, x to the power of 4, x to the power of 5. So in totality, in this case, we are getting 5 possible ways in which we can generate a term of x to the power of 9. The other possibilities are when terms of x gets multiplied with that of x square and that then further gets multiplied with x to the power of 6. One possibility. The other is x, x cube and x to the power of 5. They are on multiplication going to give you x to the power of 9. And finally, x square, x cube and x to the power of 5. So these are a total of 8 possible ways in which we can get the term of x to the power of 9, and therefore the coefficient of x to the power of 9 is 8, which is the answer for this question. Let's move to the next question, that is question number 42. In this question, we are given an ellipse whose equation is x square by 9 plus y square by 5 equal to 1 with foci at f1 0 and f2 0. f1 is positive, f2 is negative. Further, we are given 2 parabolas P1 and P2, both having their vertex at 0, 0. P1 is having its foci at f1 comma 0 and P2 with its foci at 2f2 comma 0. T1 is a tangent to P1, T2 is a tangent to P2. Their slopes are given and we need to compute some expression related to their slopes. Okay, let's come to this diagram first. If we need to calculate F1 and F2, firstly, can I say that eccentricity of that ellipse can be computed as root over 1 minus 5 by 9, that is 2 by 3. If eccentricity is 2 by 3, can I say that F1 will be 2 and F2 is minus 2. For the parabola which is having its focus at 2 comma 0, its equation will be y square equal to 8x, and for the parabola which is having its focus at 2f2 comma 0, that is basically that point will be minus 4 comma 0, its equation will be y square equal to minus 16x. Further, we are given that a tangent drawn to the parabola P1, which is T1, that passes through 2f2 comma 0. That is, this is what is happening. If you are drawing a tangent line to this parabola, that tangent line is passing through the point 2f2 comma 0, and further T2, which is a tangent to P2, that is passing through F1. So this is what is basically happening. This line is T1, this line is T2. Okay, since we know the equations of the parabolas, for P1, can I say that equation of tangent in terms of its slope is y equal to m1x plus a by m1. Note that a in this case is 2. Since that line is passing through minus 4 comma 0, we can write 0 equal to minus 4 m1 plus 2 by m1. And that will give you the value of m1 square as 1 by 2. Similarly, for the parabola P2, you can write tangent in terms of its slope as y equal to m2x minus 4 by m2. Since that line is passing through 2 comma 0, we are going to get 0 equal to 2m2 minus 4 by m2. That will give you the value of m2 square as 2. What we need to find in this question is 1 by m1 square plus m2, and therefore 1 by m1 square plus m2 square will be equal to 2 plus 2, that is equal to 4, which is the answer for the 42nd question. Okay, third question is related to limits. We are given that m and n are positive integers, each greater than 1. We are next given a certain limit and its value is given minus e by 2. We need to compute the value of m by n. Okay, as far as the left part is concerned, can I write that limit as limit alpha tending to 0 e times e to the power of cos alpha to the power of n minus 1 minus 1 divided by cos of alpha to the power of n minus 1, this whole term into cos of alpha to the power of n minus 1, that divided by alpha to the power of n whole square, that into alpha to the power of 2n minus n equals to minus e by 2. Note that the sole reason of expressing that limit in this form is that once we are taking that e out, we are getting something of the form e to the power of t minus 1 by t, where t is tending to 0 when alpha is tending to 0. That is, you will be having cos of 0 minus 1, that power is tending to 0. Now e the power of something tending to 0 minus 1 by that quantity will give you that limit as 1. That is, this part is a finite limit which is equal to 1. Similarly, we can use limit t tending to 0 1 minus cos t by t square. Effectively what that implies, this limit is equal to minus 1 by 2. And therefore the limit of this entire part is going to give you the value of minus e by 2. So that is going to take place only provided this power of alpha, which is 2n minus n, should be equal to 0. That gives the value of m by n as 2, which is the correct answer for this question. Okay, let's come to the next question. In this question we are given an integral which is denoted by alpha, and then we are looking for a term which is log mod of 1 plus alpha base e minus 3 pi by 4. As far as this integral is concerned, if I am making this substitution, that is 9x plus 3 tan inverse x equal to t, that will give 9 plus 3 by 1 plus x square dx equal to dt. Utilizing this back into the integral, we will be getting alpha as integral, lower limit of integration will be 0, upper limit will be 9 plus 3 tan inverse 1, that is 9 plus 3 pi by 4. The first term is e to the power of t, and you can clearly check that this quantity is nothing else but 9 plus 3 by 1 plus x square. So what we need to integrate is this term. On integration you will get e to the power of t 0 to 9 plus 3 pi by 4. That value is e to the power of 9 plus 3 pi by 4 minus 1, and therefore log of 1 plus alpha base e minus 3 pi by 4 is equal to 9, which is the correct answer for this question. Okay, next is question number 45, in which we are given a continuous odd function which vanishes exactly at one point. Further, we are given that f of 1 is half, and these two functions are separately specified. A limit is given to us, and based on that we need to calculate the value of f of half. We are given that limit x tending to 1 f of x by g of x is equal to 1 by 14. Note that if you put x equal to 1 here, and since f is an odd function, we can clearly check that this numerator will be tending to 0. Similarly, if you are looking for g of 1, you will put 1 equal to or 1 here in place of x. Since again this integrand is an odd function, g of 1 is also going to tend to 0. That is, this limit is in 0 by 0 form. So using L'Hopital's rule, we can write limit x tending to 1 f dash x by g dash x equal to 1 by 14. And note that since f dash x is equal to f of x, small f of x, that will give you f of 1 by mod of f of 1 equals to 1 by 14. Since we know the value of f of 1, that is 1 by 2, so what we are going to get is half divided by mod of f of half equal to 1 by 14. From that place, we will be getting mod of f of half equal to 7. You can also note in this question that you are given that continuous odd function vanishes exactly at 1 point. If a function is odd, then its graph is then going to pass through origin. So this point is surely going to be on the graph. And if you check, the value of f of 1 is given to you 1 by 2. If you take the value of f of half as minus 7, that is going to be a point somewhere here, and that then clearly implies that you are going to get that function vanishing at more than 1 point, which is not possible in this case, and therefore the value of f of half is 7, which is the correct answer for this question. The next is question number 46, which is related to vectors. In this question, we are given that P, Q, R are three non-coplanar vectors. Their components next is question number 46, which is related to vectors. We are given P, Q, R as three non-coplanar vectors. There is another vector S whose components along P, Q, R are given. The component of this vector is along minus P plus Q plus R, P minus Q plus R, and minus P minus Q plus R are also given as X, Y, and Z respectively. Okay. Note that we can take that vector S as X times this vector plus Y times this vector plus Z times this vector. We can then rewrite that vector S as minus X plus Y minus Z times P vector plus X minus Y minus Z times Q vector plus X plus Y plus Z times R vector. Using the initial information of this question, we are also given that minus X plus Y minus Z equal to 4, X minus Y minus Z equal to 3, and X plus Y plus Z equal to 5. On solving these equations, we will be getting X as 4, Y as 9 by 2, and Z as minus 7 by 2. In which case, the value that we need to compute, that is 2x plus y plus z, is equal to 9, which is the correct answer for this question. Okay, the next question is question number 47. In this question we are given that alpha k is equal to cos of k pi by 7 plus I sin k pi by 7. And we need to calculate the value of summation k going from 1 to 12 mod of alpha k plus 1 minus alpha k divided by summation from k equal to 1 to 3 mod of alpha 4k minus 1 minus alpha 4k minus 2. This is what we need to come. Know that the initial information, that is alpha k is cos k pi by 7 plus I sin k pi by 7. From that place we can clearly see that alpha k is equal to e to the power of I 2k pi by 14. That is alpha k to the power of 14 is equal to e to the power I 2k pi. What we can say from this place is that alpha k they are actually representing the roots of this equation z to the power of 14 equal to 1, which are clearly going to lie on a circle on the iron plane. And do that, we can say that clearly the vertices of that, or the roots of those equations, are basically the points on that unit circle, and they are going to constitute the vertices of a regular polygon. If you look at this term, that is alpha k and alpha k plus 1. Mod of alpha k plus 1 minus alpha k is basically giving you this side length. Since we know that mod of z1 minus z2 gives the distance between the complex numbers z1 and z2. If I am assuming the side length to be a, since the limit of summation are going from 1 to 12, we are going to get 12 into a in the numerator. Similarly, in the denominator, we can also say that alpha 4k minus 1 and alpha 4k minus 2 are again consecutive vertices of that regular polygon. Since there are 3 such terms in the denominator, that sum is effectively going to be simplified to 3a, and therefore the ratio that we are looking for is 4, which is the correct answer for this question. Next question is question number 48, which is related to progressions. We are given that all terms of an AP are natural numbers. We are also given that the ratio of sum of first 7 terms to the sum of first 11 terms, that is S7 upon S11, is 6 by 11. Using this, we can write 7 by 2 2a plus 6b upon 11 by 2 into 2a plus 10b equal to 6 by 11. Simplifying this equation, we will be getting a equal to 9d. It is also given that the seventh term lies in between 130 and 140. Seventh term will be a plus 6d, which is lying between 130 and 140. If I am substituting over here a as 9d, what we will be getting is 15d is less than 140 and is greater than 130. We can clearly check that the only possible value of d, since the terms of the AP are natural numbers, is 9, which is the correct answer for this question. Next question is question number 49, which is the first question of section 2 in this set. We are given f and g are continuous functions, are twice differentiable on the interval open -1 to 2. Further, we are given the values of these two functions f of x and g of x at -1, 0 and 2. We are also given that the function f double dash minus 3g double dash never vanishes in each of the intervals -1 to 0 and 0 to 2. Based on that, certain options are given as far as solutions of f dash x minus 3g dash x equal to 0 is concerned. Let us assume a new function in this case. Let h of x is equal to f of x minus 3g of x. Now we can observe that h of -1 is 3, h of 0 is 3 and h of 2 is also 3. In which case we can say that Rolle's theorem is applicable to h of x on each of the intervals -1 to 0 and 0 to 2. Now, using Rolle's theorem in -1 to 0, we can say that h dash x equal to 0, that is f dash x minus 3g dash x equal to 0 has a root in -1 to 0, or precisely we can say that at least one root in -1 to 0. Similarly, we can say that h dash x vanishes at least one point in this open interval 0 to 2. Note that if we'll be going in for a contradiction, that is, we'll be assuming that h dash x is 0 at more than 1 points within any of these intervals, then again using Rolle's theorem we can say that h double dash x has to be 0 between those two roots of h dash x equal to 0. But since clearly we are given that h double dash x never vanishes over those two intervals, that precisely says that h dash x equal to 0 has exactly one root in -1 to 0 and exactly one root in 0 to 2. And therefore we can check from the options that options B and C are correct for this question. Next question is question number 50. In this question we are given f of x as this much for all x in open interval -π/2 to +π/2. And then options are related to integral of x f of x and integral of f of x over the intervals 0 to π/4. Okay. In this function, from the first and from the third term, am taking tan square x common, that will give you f of x as 7 10 to the power of 6x minus 3 tan square x into 1 plus tan square x, which can be written as sec square x. If we are computing integral from 0 to pi by 4 x f of x dx, that is this integral, now we will be applying integration by parts here, taking x as the first function. The result will be x into 10 to the power of 7x minus tan cube x, limits going from 0 to pi by 4, minus integral of derivative of x, which is 1, integral of the second function, which is 10 to the power of 7x minus tan cube x, limits going from 0 to pi by 4. Now this can be checked that the first term is 0, and from the term in the second integral, if a common of tan cube x is taken, the remaining part will be tan to the power of 4x minus 1, which can be factorized as tan square x minus 1 into tan square x plus 1, which is sec square x dx. In this integral, if you are taking tan x as, let's say, t, that will reduce the integral to negative of integral from 0 to 1 t to the power of 5 minus t cube dt, and that will be equal to 1 by 4 minus 1 by 6 equal to 1 by 12. So one of the options which is correct is option A. As far as B and D are concerned, that is integral from 0 to pi by 4 f of x dx, that is 7 10 to the power of 6x minus 3 tan square x into sec square x dx, that will be clearly equal to tan to the power of 7x minus tan cube x, limits going from 0 to pi by 4, and this is equal to 0. So option B is also correct, and therefore the correct options for this question are options A and B. Next is question number 51, which is related to estimation of an integral. We are given f dash x equal to 192x cube upon 2 plus sine to the power of 4 pi x. F of half is given 0, and then certain upper and lower restrictions are given for integral of f of x from half to 1. We are looking for the values of small m and capital M. If you will observe the denominator, that is 2 plus sine to the power of 4 pi x, firstly it can be clearly noted that that term 2 plus sine to the power of 4 pi x is going to vary between 2 and 3, and therefore its reciprocal is going to vary between 1 by 3 and 1 by 2. In which case can I say that f dash x is going to be greater than or equal to 192 x cube upon 3 and less than equal to 192 x cube upon 2. If then we are integrating each term of this integral from half to x, that is, this is what we are going to perform. On integrating each term of this inequality, we will be getting 192 by 12 into x to the power of 4 minus 1 by 16. That is the integral of the first part, that is this part, less than or equal to integral from half to x f dash x dx less than equal to 192 upon 8 into x to the power of 4 minus 1 by 16. Note that this term we can further write 16x to the power of 4 minus 1 should be less than or equal to f of x minus f of half, which is given to you as 0. This is going to be less than or equal to 24x to the power of 4 minus 3 by. We are looking for integral of f of x from half to 1. So let us further perform integration from half to 1 of each term. You will be getting 16x to the power of 5 by 5 minus x from half to 1 less than equal to integral from half to 1 f of x dx, which in turn is going to be less than or equal to 24x to the power of 5 by 5 minus 3x by 2 from half to 1. If you compute these two values, will turn out to be 2.6 and 3.9, and therefore from the choices which are given to us, the correct answer is option D. Question number 52 is related to quadratics. We are given that S is the set of all non-zero real numbers alpha such that the quadratic equation, which is alpha x square minus x plus alpha equal to 0, has two distinct real roots, x1 and x2. Note that if the roots are distinct, we can say that discriminant, which is 1 minus 4 alpha square, that is going to be greater than 0. And what that implies is alpha belongs to open interval minus 1 by 2 to 1 by 2. It is further given that the roots satisfy the inequality, which is mod of x1 minus x2 equal to 1. And you can write this as 1 by alpha square minus 4 under square root, that is going to be less than 1. Okay, in which case from this place we can write that 1 minus 4 alpha square divided by mod of alpha will be less than 1, and therefore 1 minus 4 alpha square is less than alpha square, and therefore alpha square is greater than 1 by 5. That is, alpha belongs to over interval -1 minus infinity to -1 by root 5 union 1 by root 5 to infinity. Now if we are taking the intersection of 1 and 2, that will then give choices A and D as the correct answers. Question number 53 is related to inverse functions. We are given alpha equal to 3 sin inverse 6 by 11 and beta equal to 3 cos inverse 4 by 9. Okay, note that 6 by 11 is greater than 6 by 12. That is half, and therefore we can say that sine inverse of 6 by 11 will be greater than sine inverse of half. Sine inverse of half, since s equal to pi by 6, therefore you can say that alpha is greater than pi by 2, slightly greater than pi by 2, in which case cos alpha, since alpha is falling in second quadrant, will be negative. So D is correct. As far as beta is concerned, since 4 by 9 is going to be less than 4 by 8, and therefore cos inverse of 4 by 9 will be greater than cos inverse of half, since cos inverse is a decreasing function, and therefore beta is going to be greater than pi. That is falling in the third quadrant, so sine beta is less than 0. Also note that since alpha is greater than pi by 2 and beta is greater than pi, therefore alpha plus beta is greater than 3 pi by 2, which implies that cos of alpha plus beta is going to be positive, since alpha plus beta is falling in the fourth quadrant, and therefore the correct options for this question are B, C and D. Next question is question number 54, which is related to common tangents with ellipse and circle. E1 and E2 are ellipses with their major axis respectively along x and y axis. S is a circle which is x square plus y minus 1 whole square equal to 2. The straight line x plus y equal to 3 touches S, E1 and E2 at PQR. The distances PQ, PR are given, and certain options related to eccentricities of E1 and E2 are also given. Let us take the equation of E1 as x square by a square plus y square by b square equal to 1, a greater than b, and E2's equation as x square by c square plus y square by d square equal to 1 with c less than d. Firstly, we need to compute the point P, for which we will need to solve the circle and the line, which is x plus y equal to 3 simultaneously. If we are eliminating, let's say, y, we will be getting x square plus 2 minus x whole square equal to 2. That will give 2x square minus 4x plus 2 equal to 0. That is x minus 1 whole square equal to 0. And therefore x is 1. And what that implies, that point P is 1, 2. Since we know that point, in order to determine Q and R, let us first write the equation of the line in parametric form. That is x minus 1 by minus 1 by root 2 equal to y minus 2y 1 by root 2. Note that tan theta is negative. So first negative sign positive equal to plus minus 2 root 2 by 3. Taking negative and positive signs, we will be obtaining the coordinate of Q as 5 by 3, 4 by 3, and the coordinate of R can be computed as, if you will be taking the positive sign, then 1 by 3, 8 by 3. For the first ellipse, the equation of tangent at this point is x into 5 by a square plus 4 into y by b square equal to 3. Let's say that equation is the first one. For the second ellipse, the equation of tangent at 1 by 3, 8 by 3 is x by c square plus 8y by b square equal to 3. If we will be comparing these two equations, the value of a square is 5, b square is 4, and that will give e1 square as 1 by 5. Similarly, if we will be comparing this equation with x plus y equal to 3, the value of c square is 1, the value of d square is 8, and that will give the value of e2 square as 7 by 8. If we look at the options, e1 square plus e2 square is turning out to be 43 by 40, that is option A is correct, and e1 into e2 is turning out to be root 7 by 2 root 10. And therefore the correct options for this question are options A and B. Question number 55. The diagram for this question is drawn here. H is a rectangular hyperbola. X square minus y square equal to 1. S is a circle with center at x2, 0. The common tangent to H and S at P, which is x1, y1, intersects the x-axis at the point M. Firstly, the tangent at x1, y1 to the hyperbola is x1 minus y1 equal to 0. To determine the point M, put y equal to 0. That gives the coordinate of M as 1 by x1, 0. Also note that PM and PN are perpendicular, therefore we can write x1 by y1 into y1 minus 0 by x1 minus x2 is equal to minus 1. And that implies x2 will be equal to 2x1. Now if we look at the centroid of triangle PMN, the x coordinate is L, that will be equal to 1 by x1 plus 3x1 divided by 3. The y coordinate, which is M, will be equal to y1 by 3, and we can also write y1 as root under x1 square minus 1. Now since L is this much, you can clearly write dl by dx1 as 1 minus 1 upon 3x1 square. That gives option A as the correct answer. dm by d by 1 is 1 by 3. That gives option D as the correct answer. And dm by dx1, that value will be equal to x1 by t root under x1 square minus 1. And the correct answers for this question are A, B and D. Next question is question number 56, in which we need to find A and L for which this equation is satisfied. For that, one possible way is, let us assume that I of k is equal to integral from 0 to k pi e to the power of t sine to the power of 6at plus cos to the power of 4at dt. If we will be finding out I dash k, that will be equal to e to the power of k pi into sine to the power of 6 ak pi plus cos to the power of 6 ak pi into pi. This is I dash k, which you can clearly check that for any even value of a, this entire term is going to become 1. That is, this term will become 0, this term will become 1. That is, for any given value of a, I dash k will be equal to pi e to the power k pi. Since in the options given a equal to 2 and 4 is what in which we are interested here, if we are integrating this, I of k will be equal to e to the power of k pi plus some constant of integration, let's say c. Since we also know that I of 0 is 0, that implies c is minus 1, and therefore I of k is equal to e to the power of k pi minus 1. What that implies is the ratio, which is I4 upon I1, that will be equal to e to the power of 4 pi minus 1 by e to the power of pi minus 1, and therefore options A and C are correct for this question. Next is section 3, first paragraph. N1, N2 are number of red and black balls in box 1, N3 and 4 number of red and black balls in box 2. First question, that is 57, says one of the two boxes was selected at random and a ball was drawn from it randomly. The ball was found to be red. That is, we are talking about some given condition. We already know that the ball drawn is red, and the probability that this red ball was drawn from box 2 is 1/3. That is what is given to us. Okay, if I am assuming that E1 is the event that box 1 is selected, E2 is the event that box 2 is selected, and R is the event that ball drawn is red. Note that the ball which is drawn can come from any of the boxes, box 1 or box 2, and therefore the required probability that given the ball is red, the probability that it came from box 2, that will be equal to P of E2 into P of R given into divided by P of E1, P P of R given E1 plus P of E2 into P of R given E2. That is equal to N3 upon N3 plus N4 divided by N1 upon N1 plus N2 plus N3 upon N3 plus N4, and this value is given to us as 1 by 3. Note that since both PE1 and PE2 is equal to half, I have cancelled out that factor from numerator and denominator. If you check from choices, the options satisfying this are options A and B, which are the answers for this question. Question number 58, which is also related to the same passage, the same paragraph, talks about a ball is randomly transferred from 1 to 2 and then a ball is drawn from the first box after this transfer. If the probability of this is 1/3, then correct values of N1 and N2 are. Let us further assume that let E3 be the event that red ball transferred and E4 be the event that black ball is transferred, and therefore the probability of drawing a red ball is going to be P of E3 into P of R by E3 plus P of E4 into P of R by E4. The probability of transferring a red ball is N1 by N1 plus N2, in which case the probability of drawing a red ball from the first box will be N1 minus 1 by N1 plus N2 minus 1. The probability of transferring a black ball is N2 by N1 plus N2, in which case the probability of drawing a red ball is going to be N1 by N1 plus N2 minus 1. This probability is given to us as 1 by 3, and the correct options which are satisfying this equation are options C and D. The second paragraph is talking about a function which is thrice differentiable. Values at 1 is 0, at 3 minus 4, and these are the further informations which are given to us. Option A is talking about f dash 1. Note that if we will be differentiating this, then f dash x will be equal to this much, and therefore f dash 1 will be equal to this much. We are given that this quantity is 0 and f dash x, capital F dash x is always negative, and therefore we can say that option A is correct. For the second option, from this fact, that is this derivative is always negative, can I say that this is a decreasing function? Also, we are given that the quantity which is f of x, that is going to be negative Next is question number 5960, that is the paragraph 2. We are given a thrice differentiable function and some information related to those. In the question number 59, option A talks about f dash 1. If we are differentiating this, f dash x will be equal to this much. Which clearly gives f dash 1 equal to this much. And using this information, we can say that this quantity is negative. So A is a correct option. Also, since we are given this derivative is less than 0, so the function is a decreasing function. Also, if you look at these values, f of 1, 0, f of 3, minus 4, function is decreasing. We can say that this function is negative for x belonging to this interval. In which case, we can clearly say that f of 2, which according to this will be equal to 2 into capital F of 2. Since that 2 lies in this interval, this quantity is negative, and therefore option B is also correct. For option C, over the interval 1 to 3, it will compute this quantity. This is equal to 0, and f of 3 is equal to this much. We are given the function is thrice differentiable, and since values at 1 and 3 are unequal, using mean value theorem, we can say that the derivative is not going to vanish anywhere in the interval 1 to 3. So option C is also correct. The correct options for this question then are options A, B and C. In the paragraph 2, question number 60, we are given that integral from 1 to 3 x square f dash x dx is equal to minus 12, and another integral is given. Okay. In the first integral, if we are using integration by parts, taking x square as the second function, we will be getting x cube upon 3 into capital F dash x 1 to 3 minus integral x cube upon 3 f of x dx going from 1 to 3, or in question number 16, further these two integrals are given. In the first integral, if we are using integration by parts, we can write x cube upon 3 f dash x from 1 to 3 minus integral x cube upon 3 f double dash x dx from 1 to 3 is equal to minus 12. That is what we are going to get after applying integration by parts on the first integral. this value is 9 times f dash 3 minus this much. Note that this value is given to us as 40, that will be equal to minus 12. Also, the initial information, that is this, that gives us f dash x equal to this much. Okay, so from that place, if you are putting x equal to 3, that will give 3 f dash 3 as this much minus 4, which will become plus 4, that into 3 minus 1 by 3 into this quantity can be written as f dash 1 minus this value, which is 0, that is equal to 40 by 3 minus 12. So what we are having here is 3f dash 3 minus 1 by 3 f dash 1 plus 12 is equal to 4 by 3, and therefore 9 f dash 3 minus f dash 1 plus 32 equal to 0. Utilizing that, we can see that option C is correct. In the options B and D, they are talking about the integral of f of x from 1 to 3. So if I am considering the integral of 1 to 3 f of x dx can be written as integral from 1 to 3 this much. If we are applying integration by part over here, we will be getting note that the integral over here is already given to us, and then if we will substitute the values in this, we will get the answer as minus 12, which is option B. And therefore the correct answers for this question are options C and D.